Take a technical deep dive session for VeloCloud by VMware SD-WAN. What we are going to talk in this session is all about the application performance which is provided by the DMPO functionality, which is the dynamic multipath optimization. We'll talk about that in details, how we achieve or how we assure application performance. Then we'll go over to the Cloud VPN section. We'll showcase you the simplicity which is built into the Cloud VPN. It's the simplicity, it's the flexibility for an enterprise or a service provider for the Cloud VPN. Then we'll talk about outcome-driven networking, where we have key features like outcome-driven routing, segmentation, application performance. It's where the customer defines the outcome, and with simplicity from the orchestrator, we are able to achieve that outcome. We'll go over the segmentation. We'll also go over the workflow for the segmentation from the UI. And then we'll talk about different network flow scenario. For example, if the traffic is going to the internet, what are different ways the traffic can go to the internet? Let's say using backhaul all the way to the internet, or through the cloud gateway, or using cloud security like service insertion. So we'll go over those scenarios. Application performance using DMPO. DMPO again, dynamic multipath optimization. VeloCloud cloud delivered SD-WAN solution enables enterprises and service provider to utilize multiple WAN transports simultaneously, where they can maximize the bandwidth at the same time assuring application performance. So the unique architecture what VeloCloud SD-WAN has benefits both on-premise and cloud-based applications. And this requires building up overlay networks. So we build up those VPN tunnels, those overlay networks on all the physical WAN circuits in real time. We monitor them real time 24/7, and then we dynamically switch over or do on-demand remediations to applications when those WAN circuits performance deteriorates. So for this to happen, VeloCloud SD-WAN has developed a feature called as dynamic multipath optimization. Remember that this dynamic multipath optimization, it is used between all those VeloCloud components that processes and forward the data traffic. And what are those components? The edge device, the CPE device, which is on the customer premise, and the gateways. The gateways could be on premise or in the cloud. So for connectivity within the enterprise location, let's say branch to branch or branch to hub, the VeloCloud edge devices establishes those overlay tunnels between themselves. So these overlay tunnels are built from the edge device to the gateway, or from edge device to the other edge device. And on these overlay tunnels, when the traffic is sent, we are monitoring this tunnel 24/7. We are monitoring every 100 milliseconds, and we are reacting to any changes in these WAN circuits in sub-second fashions. So there are four key components to the DMPO functionality. One is that we continuously monitor these circuits. Second is dynamic application steering. When there is an issue with those WAN circuits, or because of those WAN threshold going down, we immediately move those application flows or packets from one circuit to the other, or we do on-demand remediation. So continuous monitoring, dynamic application steering, on-demand remediation, and then QoS. And the QoS is application aware QoS, which happens onto that overlay. And talk about how the DMPO is achieved: dynamic multipath optimization, application assurance. Before we could take those actions on the WAN circuits, First, we need to recognize the application. So every edge device runs a little piece of software, what we call it as deep application recognition engine. So every CPE device on the branch site or on the data center, when they receive a packet from the LAN site, they are analyzed. We today, with that deep application recognition engine, we can recognize 2500 plus different applications. So we do a deep packets inspection, and then we learn the database. We cache those packets, and the next time the same packets or the same flow coming in, we can recognize what application it is for. Also, that deep application recognition engine has a built database of those cloud applications IP addresses. So it is a combination of DPI, where we recognize application, it's the learning database, and those cloud services directory, where like Salesforce has released a bunch of IP addresses where their services are running, which are released by Salesforce, which is publicly available. And we get those IP addresses and we implement them in our deep application recognition package. And that's how, when the next time the flow comes and we check the destination IP, or this destination IP belongs to a SaaS server, which is part of Salesforce, then we can directly move that packet to the cloud gateway. Let's next talk about once the packet is on to the WAN circuits, what we do to assure the application performance. So what we do is we continuously monitor the links. Second, we do dynamic per packet steering, and the third is on-demand remediation. With all of this, we also maintain a quality score, a quality matrix in the orchestrator, where the end user or the enterprise admin would be able to see what exactly happened at a particular time frame. So you can see here at a given time around this 5:50, the MPLS circuit went down. And that's the time when the voice packet was moved to the Comcast. But at that very given time, we could see there was some packet loss. So at this time, there were some on-demand remediation might have happened, which is the forward error correction, which was kicked in dynamically by VeloCloud SD-WAN solution. And this is what it gives you, the before and after. So what does this mean is, during this time, your call wouldn't have dropped. So per packet steering happening at the same time, on-demand remediation, which is happening. And how we do that? We continuously monitor the link. The moment you connect the WAN circuits to the edge device, we build up those overlays. Once the overlays are built up, we run the bandwidth test with the closest VeloCloud gateway. And the bandwidth test is performed by sending short bursts of those bidirectional traffic and measuring what rate we are getting at each end. Since the VCGs are already deployed on the internet, it can also identify, auto discover service provider IP address, service provider name. It can all do that. It knows which interface it is connected, so it will auto populate all those information. Next comes, once the overlay tunnels are built up, we do unidirectional measurement for the performance matrix. And what are those performance matrix which can affect an application is loss, latency, jitter for every packet on every tunnel between two endpoints. Those endpoints could be edge device to the gateway, edge device to the other edge device, or from edge device to the hub. VeloCloud per packet steering allows independent decision in both uplink and downlink directions without introducing asymmetric routing, because we have a sequence number and time for the packet. So we do both passive and active monitoring. We do both passive and active probing. When the user traffic is present, we will carry the DMPO tunnel header is going to have additional performance matrix, including the sequence number timestamp. So we can identify out of order packets. We can calculate the latency and jitter in each direction, from edge device to the gateway, from the gateway to the edge device. Now these performance measurement happens every 100 milliseconds. And when there is no user traffic, an active probe is sent every 100 milliseconds. And after 5 minutes of no high priority user traffic, we kind of reduce the probe frequency. What happens with that? The matrix, the information which we are collecting, what it enables our DMPO feature, dynamic multipath optimization feature, to react very quickly to any changes in the WAN circuit. So we are able to deliver sub-second protection against blackout or brownout protection in the blackout or brownout condition in the WAN. Blackout is where the link has completely gone down. Brownout is where the link has not gone down, but the link conditions have changed. You remember those latency, jitter, and packet loss? Those are the link conditions I'm talking about. So it's the continuous monitoring we are doing. In continuous monitoring, again, automatic bandwidth discovery we do. Continuous path monitoring is happening as part of the link monitoring feature. So now let's talk about dynamic per packet steering, application aware per packet steering, which is part of the DMPO functionality. Now, DMPO identifies traffic using those layer 2 to layer 7 attributes: VLANs, IP address, what protocol, applications. Now, VeloCloud SD-WAN DMPO functionality performs application-aware per-packet steering based on the business policy the end user has configured. Now remember, for each and every applications, or those 2500 plus different applications which we recognize, we don't go and manually configure the business policy for them. There are smart defaults already out of box. So you don't have to worry about configuring each and every business policies for each application. Don't get me wrong. You can go and do the customization. Even you can define your own custom applications. But customers can immediately use the dynamic packet steering and the application aware prioritization without having to define any policy. I mean, you don't have to define the policy for each and every application. So throughout its lifetime, a single traffic flow can be steered onto one or more overlay tunnels. Even in the middle of the communication, with no impact to the flow, we can steer the packets from one overlay to the other overlay. A link that is unable to deliver an SLA for an application, we refer to it as a brownout condition. Blackout is where the link is completely down. And this is where the VeloCloud by VMware SD-WAN solution offers the sub-second blackout and brownout protection. There are many vendors in the market, SD-WAN vendors in the market. They do blackout completely well because they move the flow. They move the flow completely from one overlay tunnel to the other. But what VeloCloud by VMware has the unique advantage is that in the middle of the communication, when the brownout condition happens, instead of moving the complete flow, we can move the packets from that flow. And how we are able to achieve that? Remember, because of that deep application recognition engine, where we first recognize the application, the business policies which are defined by the end user, and then by continuously monitoring all the WAN links. We monitor all the WAN circuits, and that's where we detect any blackout or brownout conditions, and immediately we steer the traffic flow to protect the application performance. At the same time, we make sure that the flow is intact and the user experience is saved. Intelligent learning enables application steering based on first packet of the application by caching the classification result. And this is important when it comes to the deep application recognition engine. Second thing is those business policies where you don't have to define business policies for each application. They are out of the box smart defaults already defined for you. Depending on the application, we perform either link steering, or we could do on-demand remediation, or I could even do bandwidth aggregation. So if it's a real-time application, it will be in middle, will steer the packets from one overlay tunnel to the other overlay tunnel. If I see my application as, let's say, a bulk application, FTP download or a box download, I will do the bandwidth aggregation. You don't have to define a policy that if you see an FTP download, do bandwidth aggregation. It happens on demand. That's why the DMPO is smart enough. It recognizes the application and then performs actions on demand. So to give you a use case about the bandwidth aggregation, and we are going to talk about it in the coming slides. Let me show you here. The moment I see there is a box download happening, and this is where I can benefit from more bandwidth, DMPO performs per packet load balancing. It will utilize all the available links to deliver all of the packets of that single flow to the destination. And on the other side, I will do the reordering of the packets if the packets are utilizing all the links. So to give you an example, 250 meg links deliver 100 meg of aggregated capacity for a single traffic flow. Now QoS will be applied at both the aggregated and at the individual link level. So you can see here, even with 2% packet loss, without VeloCloud SD-WAN solution, it took around 134 seconds to download a 50 meg file. With VeloCloud, what we are doing? On-demand remediation, forward error correction happening because there is a 2% packet loss. Packets are sent on both the WAN circuits. We are utilizing both the WAN circuits. How? By building up those overlay tunnels on both the WAN circuits. And with 13 seconds, which is 10 times faster, we are able to do the download. There are other use cases, we'll talk about it. So continuous link monitoring, dynamic per packet steering. The third piece to this DMPO is on-demand remediation for those real-time applications. And this works even on a single link. That's an important concept because when customer has a single link, there is no way to do link steering. And that's where on-demand forward error correction kicks in. And this is where just showing you a use case for a real-time application. In a scenario where it's not possible to steer the traffic flow onto a second link or to a better link, for example, single link deployment, or maybe you have multiple links and all the links are having, most of the links are having issues at the same time. And this is where the DMP or dynamic multipath optimization can enable error correction for that duration of disruption. And it will kick in that error correction on demand. What kind of application gets benefited with this? These are those real-time applications such as voice and videos flow. DMPO again will automatically enable forward error correction on a single or a multiple link. With multiple links, DMPO will select up to 2 or maybe more best links at a given time for forward error correction. It will start duplicating packets, but then duplicate packets on the other end will be discarded. Out of order packets will be reordered because we are having a sequence number and a packet number to each, sequence number and time stamp to each packet. At the same time, we also enable jitter buffering for real-time applications where in the WAN circuits we experience jitter. So this was for the real-time application. What happens to the TCP based application? We do negative acknowledgement at the same time for those. Once we detect that there are missing TCP packets, DMPO will inform the other end that, hey, why don't you retransmit those missing packets? So doing so, what happens? It protects the end application from detecting packet loss, and as a result, it maximizes the TCP window size and deliver high TCP throughput during those lossy conditions. While all this is happening, we also maintain a quality score, quality of experience. From the orchestrator, the end user can check out how my links are working for a particular application. If my traffic type is voice, how the Comcast cable and the EXO communication in this case is working for me. The moment you see those yellow and red marks, it means there are issues on the underlying WAN circuits, and that's where either the link steering is happening or on-demand remediation has kicked in. And that's how we monitor and we provide you with a score. These are just the thresholds. The key thing here is that the assessment monitoring of those overlay tunnels are done every 100 milliseconds, but then we react to those conditions in sub-second fashion. That's the key here. Now, from the business policy framework, where there are smart defaults already defined for each application, you can do customization at the same time. Just to give you one example here, mandatory. So you can select a link steering option as mandatory, where you are pinning a traffic to a particular link. Maybe I want a PCI traffic to always go on a particular link. What happens in that case? When we do a mandatory on that link A, if the link A goes down for some reason, we are not going to steer that application to the other link. In case of mandatory, we are not going to do that. Maybe because of the business policy or because of the enterprise customer need or PCI compliance, they don't want to steer that traffic to an internet link. They want to always send it on a private circuit. So for those scenarios, we have the flexibility in our business policy framework. The second option is the preferred option, where if you prefer link A for an application, and if link A goes down or the link condition changes, we immediately steer the application to the other link. And when the link A condition improves or the link A comes back online, we move back the traffic to the preferred link. The third option is the available. Same, we move the application to link B when the link A condition changes or the link A goes down. But we'll keep on sending the application on this link B. Will not steer it back to link A if that link comes back online, because it is not a preferred link. But we'll steer it back when link A condition are better or improves. Or maybe if link B condition deteriorates, that's where we'll move it back to link A. So we have options, we have the flexibility from the business policy framework. At the same time, we have a 3 by 3 matrix defined for the traffic class. That 3 by 3 matrix depends on the high, normal, low priority, and with the service class real time, transactional, and bulk, resulting in a 3 by 3 matrix with 9 traffic classes. And then we give a weight or a percentage to an application. So if it's a real-time application which is marked as high, it will get 35% of the aggregate bandwidth. So if you have a 100 meg bandwidth, total aggregate 100 meg bandwidth, a real-time and a high priority application will get 35% of it. So all applications within a traffic class will be applied with this aggregate QoS treatment. When there is no congestion, that's the time applications are allowed to burst up also at the same time. But a policer can be applied to cap that bandwidth for an application in a defined or in a given traffic class. But all those 2500 plus different application has to fall under this 3 by 3 matrix. To give you an example again, let's say a customer has a 90 meg internet link and a 10 meg MPLS on the edge. So the aggregate bandwidth here is 100 meg. So based on the default weight and traffic class mapping above, all application that maps to business collaboration will have a guaranteed bandwidth of 35 meg, and all application that maps to email, let's say, will have a guaranteed bandwidth of 15. Business policies can be defined for the entire category like business collaboration, or maybe for an application like Skype for Business, or maybe you can go more granular sub application level where you can say Skype file transfer or Skype audio. So you could have a scenario where you are blocking a Skype audio call, but you at the same time you are allowing Skype video. QoS marking for the service provider, this is helpful because then we are in sync with the service provider. If the service provider has given a DSCP tag, we can match that. We can apply that DSCP value to the outer packet. We can mark it. And you can see here with the business policy, we can either mark the inner packets or even the outer packets, or we can send as is. DSCP is the differentiated service provider code point, which are marked by the customer and can be left as is, or you can modify it. Live about those business priority monitoring, how we can do once you have defined, if you remember the QoS where we have that 3 by 3 matrix with the service class and on the other side the priority. How do we know, how can we monitor if we are able to see a high priority traffic or not? So based on a designated priority, the application traffic can be monitored in real time. Even we can get the historical data which can be retrieved by an enterprise admin. So let's quickly see that. So we can go to monitor edges. I'm logged in as an enterprise admin. So I can go to one of the branch sites here. I can go to the business priority here, and this is where you will see, you can go back historical time and you can see how much you are seeing the normal, the low priority, or the high priority application. Now you can view byte sent and received, average throughput also. This is how you can monitor those. Now let me go back to that business policy framework. Let's try to understand the business policy framework here. Remember, we can recognize 2500 plus different applications. So you don't have to define business policy for each and every applications. There are smart defaults built in. You can go and change it, but at the same time, you can define your own new rule also. And those new rules, you can define it based on the source, destination, or application. Or even we can go sub granular level. So the DMPO makes those steering decisions based on the application type, real-time links conditions, any congestion, latency, jitter, or packet loss, and the business policy. So each application which you define has to go through this business policy framework. This is where you define what needs to be done to an application. But then each category also has a default action, which is a combination of your traffic class and the priority. So let's talk about the traffic classes here, what actions can be performed. So you can see the match criteria here, and then what actions can be performed. This is what builds up the QoS, where we have the priority and the service class. High, normal, low. You can also do the rate limit, both uplink and the downlink direction also. I can define an application here. So let's say I do YouTube, and then you remember I talked about the sub application. This is where you can define it. So in the match criteria, I can define the source also based on the VLAN or the IP address or even the port number. Same goes with the destination. I can define all internet traffic, what protocol, and the port number. Maybe I can define 8080. After the match criteria comes the action, where we have these network services, direct, multipath, and the internet backhaul. Let me remove this application to any default, and that's where we'll see other parameters here. So let me say any here. Let me switch it back. Yes. So here we have the network services. Direct, the moment you select direct, it means the traffic is maybe a non-critical application. To give you a use case where Netflix, a service that is considered to be a non-business, high bandwidth application, and we don't want to send that Netflix low priority or a non-business critical application over the overlay tunnels. We want to send it directly underlay. But by default, all the low priority applications are assigned as direct behavior, direct network services. This is where the moment you select direct, it means the traffic is not going to go on the overlay tunnels. When the traffic doesn't go on the overlay tunnels, it goes directly underlay. There is no DMPO for the direct traffic. The second is multipath. Typically given to important applications. Multipath service assignment sends the internet-based traffic to the gateway. All the traffic from the edge device goes to the gateway. And this is where we have that on-demand sharing, on-demand remediation, on-demand link sharing happens. And by default, all the high priority and the normal priority applications are given the multipath action for the network services. Multipath, it will select all the paths at any given time. If you have a single flow with 10 packets, maybe 5 packets will go on overlay tunnel 1. The other 3 packets can go on overlay tunnel 2. And then on the gateway on the other side, the reordering will happen. Why? Because each packet is marked with the timestamp and the sequence number. The third one is the internet backhaul. It redirects the internet application to a specified enterprise location, and that can be an edge device, the hub device, or maybe it's not a hub device. But a typical use case would be in backhauling the internet traffic all the way to the data center site, where the enterprise has a centralized firewall where they want to inspect the internet traffic or the internet application to the firewall. So that's where they will redirect the application from the edge device to the firewall, maybe for firewall or for content filtering. Now let's go to the link steering option here. The first option is auto. This is where the autopilot comes in. This is where you are giving the control to the VeloCloud by VMware SD-WAN. DMPO will have the full control. And by default, all applications are given the automatic link steering mode. This means the DMPO automatically picks the best link for you based on the application type and the application priority. And wherever necessary, it will do on-demand remediation and it will do link steering also. And this is where the automation comes to play. When it's to give you an example, when it's a real-time application, it will do per packet steering. With on demand, it will do forward error correction, it will do jitter buffering. When it's a bulk application, it detects a bulk application, it will do load balancing, it will do the aggregation of all the links so that you have more bandwidth to download the file. Link steering by transport group. Next option is the transport group, where you can group all the public wired connection, because different location might have a different WAN transport, different WAN interface name from different service provider. Maybe at one location you have a public wired, or sorry, a public wireless, let's say from public wireless from Comcast, and some locations you have from AT&T. So you don't have to define the policies, business policies at each site. You can do it at the profile level, and you can select the transport group, and that's where you can select public wired or public wireless. The You can see here the interface and the WAN links are disabled here because I'm at the profile level. So I need to go at individual branch site and then do the business policy, and that's where the WAN links which are specific to that branch edge device will get enabled. So I logged on to the Chicago branch edge, and this is where you will see, let me click on a new rule here, and this is where you will see an interface becomes specific to an edge device or even the WAN links. And this is where these are the WAN links which are available on that Chicago edge device. And that's why they are enabled on an edge. Similarly, I can do WAN links also. It will give me the names of the WAN links which are available, which it has auto discovered. There are two WAN links which are connected currently, and I can select, let's say, Verizon Wireless, and I can do mandatory, preferred, and available. And then we have other options where I can say do the error correction before you do the steering. And then NAT is self-explanatory, disabled or enabled. Service class, where it can, based on the QoS, real-time transactional and bulk, and the priority, it will take care of an application using DMPO. With real-time, that forward error correction, link steering kicks in automatically on demand. With the bulk application type, again, it will do the aggregation of the link the moment it sees a box.com file transfer or an FTP. So this is where the business policy frameworks comes to play. And this is like any other access list where it goes from top to bottom. And at the bottom, we have those default rules defined. So you can have the business policy defined at the profile level or at the edge specific level. You come to edge specific level and define the business policy rule, it will override the profile business policy rules. Let's go back to our presentation, and this completes our DMPO. Let me summarize the DMPO here. Summarize the DMPO, dynamic multipath optimization. So the VeloCloud by VMware DMPO works on any of those data traffic which is between the edge device and the gateway, or edge device to the other edge device, or from edge device to the hub. It works on that UDP port 2426 because that's where the overlay tunnels are. So it enables application aware dynamic per packet steering, on demand remediation, and at the same time apply the QoS on those overlay tunnels. DMPO will ensure optimal SD-WAN performance for most of those business critical application over any transport, whether it's public, private, internet to hybrid, or and any destination, whether the destination is on premise or in the cloud. So per packet, on demand remediation. Cloud VPN, the simplicity which is built into the SD-WAN solution to do the VPN. There is a flexibility for an enterprise admin. They can do VPN from branch to a hub device, which happens in a dynamic fashion, or from branch to branch using hub, or branch to branch using gateway, or even dynamic branch to branch. There are flexibilities available to an enterprise admin. Once you log on to the orchestrator, with a single click, you can enable Cloud VPN. With this Cloud VPN getting enabled, we build up automatic overlay tunnels, VPN tunnels secured from branch to the hub. Or we could also have an option of building an overlay tunnel to a non-VeloCloud site. And we'll come and talk about that in a little bit, but then Edge to VeloCloud Hub, or even Edge to Edge VPN using Hub, or we can also do dynamic Edge to Edge. So all different permutation and combinations are available for the Cloud VPN today. And when these VPN tunnels, these overlay tunnels are built from one side to the other, they are encrypted. IQ2 encryption is available there. So the packets are secured, the overlay tunnels are secured. To give you an example, for dynamic edge to edge, initial traffic for dynamic edge to edge goes through the hub or to the gateway, whatever is selected in the Cloud VPN. But once the dynamic tunnel is up and running, then the traffic goes directly from branch 1 to branch 2. You don't have to get involved with CLIs where you need to write for each scenario. You might have to write 50 or 60 lines of config file. It's with those single click you can have the options of either doing branch to hub or from branch to branch. You just enable an edge device as a hub device, and then all the edge devices in that profile will start building up an overlay tunnel to that hub device. And let me show you through the GUI. Let me log on to the orchestrator and let me show you there. So I can go to the profile here, and let's say I go to the East Coast profile, and this is where we enable the Cloud VPN, and you can see here. Let me go back to the Cloud VPN section here. So with this single click, the Cloud VPN gets enabled, and this is where if I want to build up a hub and spoke topology, let's say. So the only thing I need to do here is define what is my hub site. So this is where I define that this is my hub device. And once I define that this is my hub device, all the sites which are available here will start building up VPN secure tunnels to this hub device. This is where the hub and spoke topology comes to play. And you can check for these VPN device from test and troubleshoot section. At the same time, I can do branch to branch VPN using a gateway or using a hub, or I could have a dynamic branch to branch VPN also. So let me go to one of the profiles here again, and let me show you. If I go to the OSPF profile, this is just a profile name for this demo here. So I can select a hub device. Let's say I select this as a hub device, and it will show me in the list. So now I have multiple hub sites. So it means all the edge devices, Chicago, LAX, and test edge device will start building up overlay tunnels, static overlay tunnels, VPN tunnels to DC1 hub site and to Dallas hub site. And let me also show you here. Once I go to test and troubleshoot, I can go to the Chicago site. And this is where if I do list path, it will show me what are the available paths where it has built up the overlay tunnels. By default on the internet, we have the gateways. So even for gateways, it will build up the overlay tunnels from the branch side. And let's go here in the list path, and you can see here I have gateway and the hub side. So if I click on run, it will show me on all the WAN circuits, it will build up the overlay tunnel to the hub side. And that's what we'll see here. You can see here, Chicago site has two links. So it has built up overlay tunnels on both the links to the hub site. So there is a flexibility involved where customers can select what kind of a VPN configuration or topology they want. Similarly, it goes with the non-VeloCloud site. Non-VeloCloud site is a site where you don't have a VeloCloud edge device. In that case, we'll build up an IPsec tunnel from the gateway to that non-VeloCloud site. Once the IPsec tunnel is built up, I don't have to build up an overlay from all my thousands of edge devices to that single non-VeloCloud site. I'm able to leverage that single IPsec tunnel from the gateway to that non-VeloCloud site because I already have a VPN tunnel from the edge device to the gateway. That way, I will be able to access the resources from the edge device to the non-VeloCloud site. Next is the outcome-driven networking. Simple and secure VPN. We just talked about those cloud VPN. You define what kind of a topology you want, whether you want a hub or a spoke topology, or you want a VPN to a non-VeloCloud site where we can eliminate N by N manual IPsec tunnels from each of those 1,000 branch sites. We build up a single IPsec tunnel from the gateway to that non-VeloCloud site, and then all the branch sites which are connected to the gateway now can access resource which is behind that non-VeloCloud site. So you define the outcome, and you can achieve that with simplicity from the orchestrator. Segmentation, where you define different segments. Let's say for a retail customer, you have a PCI segment and a guest Wi-Fi segment, where you allow social networking application on a guest segment, but at the same time on a PCI segment, you disable the social networking application. So based on the outcome or based on what results you want, you can define from simplicity. Based on that simplistic orchestrator, you can define those outcomes. You can have different topologies for different segments. Similarly, for routing, there is a single unified view for the routing table for the entire SD-WAN network. I can change the preferences or the outcome from that overlay flow control single global routing table, and we can take a look at that. So when it comes to outcome driven networking, we are talking about the service insertion, where you can insert a firewall service all the way from data center to a branch or even to a gateway where you are running some kind of a firewall services in the cloud. Zero touch provisioning of those edge devices. I can drop ship a box to a remote site. I can pre-configure that box from the orchestrator once the box is powered on in the remote site where I don't need an IT staff. Just an internet connection to that edge device, and it can talk to the orchestrator and download all the policies. And then all the provisioning, all the configuration monitoring happening from the orchestrator. All in one SD-WAN management. There is zero CLI involved. Now we talked about that outcome driven networking from the routing point of view, where I don't have to define routing policies, route maps on each and every device. And then to check the path or the route table, I go to each and individual devices and check for the IP routes. No, I can do it all from the orchestrator. If I have to change a preference, I can change a preference for a route from the overlay flow control table. Not even that, even Based on the local route preference, the OFC table will adjust the routes. So any route you push from the global routing table based on your local preferences also, it's going to work out. And I'll give you a use case for that. Let me show you that from the orchestrator here. So overlay flow control, this is where all the routes which are learned by the SD-WAN are defined here. So if I have a legacy route, let's say 192.168.16, this is my legacy route. It shows me that to reach that legacy network, which is only an MPLS network in this case, it can be either go through underlay, or it can use the data center as a transit site. So with this here, the single click, I can change the route preference. So the moment I change the route preference here, it means all the branch sites, different type of branch sites, whether they are internet only or hybrid sites, they will use the data center as a transit site to reach that legacy MPLS site. This is the default behavior, but even based on the single click, I can change the behavior of that branch site even when that branch site has a local preference defined. This is the power of that outcome-driven networking approach from the routing point of view. Same goes with the segmentation. I can define the segmentation. This is the simplest UI flow you will see for the segments. Once you define the segments, apply that segment to a profile. So let's say I apply this segment to a profile, the PCI segment which I have created. And then I can go to that profile, and let's say I select PCI segment. So for PCI segment, I'll enable Cloud VPN, but I'll do branch to branch VPN. So I'm selecting a different topology for PCI segment. I could have a separate VPN topology for a guest Wi-Fi, for a guest segment. So with segments, I'm having a separate business topology. I can have separate business firewall rules. I can have separate business policies also for an application. We just talked about this overlay flow control table. Segmentation, simple to define. I just gave you an example of that PCI and guest segment. And these segments are carried from the branch site all the way to the gateway to the data center. So end-to-end segmentation is there. Each segment we can have overlapping IP addresses also. So for guest segment, I'm using 10.3 network. Even for PCI segment, I can use 10.3 network. And this segmentation also work for the service provider triple play, where they have voice, internet, and data traffic. They can segment it, and the same segment ID is carried from the edge device, from the branch side to the service provider network, also to the gateways, and from the gateway to the data center. Even in a single CPE device, I can segment it based on the tenants. And for each tenant, we'll have a separate QoS. We'll have a separate DMPO. We'll have a separate business topologies. Now let's talk about network flows for different destinations. So I have an edge device and a hub device. And then we have two internet connection and one private circuit. So we are going to build up three overlay. So two overlays tunnels will be built onto those gateways. So I'm building up two overlay tunnels on that single internet connection, one to gateway 1, the other to the gateway 2. Then we also build up overlay tunnel from the edge device to the hub device. The moment you enable a hub device, you mark an edge device as a hub device, all the edge devices which are part of that profile will start building up overlay tunnels on public and private circuit. So even on MPLS, we'll build up the overlay tunnel to the hub device. Let's talk about the other scenario here, internet backhaul. Those overlay tunnels are built up when it's a low priority traffic, which is Netflix. That traffic is not going to go on to those overlay tunnels. It will go underlay, it will go direct to Netflix. So you can have overlay tunnels between branch to branch or branch to hub. With branch to hub, you can do internet backhaul. If the traffic is destined to box.com or any cloud service provider, it goes from the gateway. From the edge device, it builds up an overlay tunnel to the gateway. The moment the edge device is activated, it does a GeoIP lookup and it looks out for the nearest gateway and start building up overlay tunnels to both primary and secondary gateway. But the active overlay tunnel is to the primary gateway, and that's where it goes to the box.com, to any SaaS application. So the traffic for box.com will go from the edge device to the gateway, and then HTTPS to the gateway, or HTTPS to the destination. Similarly to a VPC or to a non-VeloCloud site, we build up an IPsec tunnel from the gateway to that non-VeloCloud site. So the traffic from the edge device to the gateway will be over that overlay tunnel, and then an handoff will happen to that IPsec tunnel. We talked about this underlay traffic, low priority traffic, let's say a Netflix traffic. That's the use case one, where it will go underlay, it will not go on to the overlay. Any traffic that is going direct doesn't have the DMPO functionality. DMPO only works for the overlay tunnels. Or there could be a second use case where there are only MPLS site and you want to reach that MPLS site. That's where you will use underlay traffic. That's where you will use the underlay network, MPLS network. You don't want to backhaul all the way to the hub and then go to the MPLS site. You can directly from the branch site underlay, you can reach the MPLS. You might be hearing this term overlay and underlay. Underlay means direct. Overlay means the SD-WAN overlay, which works on that UDP 2426. Management traffic always goes over the overlay to the gateway and then HTTPS to the orchestrator. But there are times when the gateways are not available, then yes, that management traffic goes from the edge device to the orchestrator. The management plane is separated from the control and data plane. So in case my edge device is not able to reach the orchestrator, data traffic is not impacted. That's very important concept here, because we follows the software defined networking principles where we have separated out the management plane, the data plane, and the control plane. So you can see here my primary path is through the gateway for the management plane traffic, but in case the gateway goes down, my secondary path is direct HTTPS to the orchestrator. Low priority traffic like Facebook or Netflix traffic goes directly from the edge device to that destination. We don't have DMP or dynamic multipath optimization for those low priority traffic. SaaS application goes through those cloud gateways. We do the GeoIP lookup and we select the nearest gateway to that edge device. And that's where the the overlay tunnels are built from the edge device to the gateway. And then from the gateway, the handoff happens to that SaaS application. The other scenario is where any internet traffic, you want to inspect it. So there are cloud security providers where VeloCloud by VMware SD-WAN has partnered with, let's say Zscaler or WebSense. So that's where the traffic is service changed from the gateway to those Zscaler provider. So you have a business policy where you define that all internet traffic needs to go to that Zscaler for inspection. So in that case, that internet traffic from the edge device goes to the gateway. From the gateway, handoff happens to the IPsec to the Zscaler, and then based on the Zscaler configuration, the traffic will be allowed or it will be dropped. If it is allowed, it will be allowed to go to that SaaS destination. Edge to edge, branch to branch VPN. It goes through the gateway or through the hub site. Or you could also enable dynamic edge to edge. The moment you define a hub site, all the branches will start building up static overlay tunnels to that hub site, building up a hub and spoke topology. And this is where the DMPO comes to play. On all the overlay VPN tunnels, the DMPO works. Edge to data center backhaul. These are some of the scenarios we talked about. So the key takeaway in this is we know how the application performance is assured by the functionality, what we call it as DMPO, dynamic multipath optimization. The second was the cloud VPN. You have the flexibility of building up different topologies, whether it's branch to spoke, hub and spoke topology, dynamic branch to branch, or even a VPN topology from edge device or from a gateway actually to a non-VeloCloud site, that IPsec tunnel. Then we talked about outcome-driven networking, where you define your outcome, what you want that outcome, and then you achieve using those simplicity which is defined in the VeloCloud orchestrator.